Hello everyone, welcome to the very first video lecture of MAT091 and 092. My name is Mehdi Noor and I am going to be discussing the topics of this course over the period of the semester. So the very first topic that we will be focusing on is the topic of functions. So what exactly are functions? In order to understand what a function is, it's best to know what a set is, right? So a set is basically just a collection of distinct objects. And usually these objects, they tend to be numbers. So if we take a look at a few examples of some sets, let's say we look at the set of whole numbers. Well, we can represent a set with these curly brackets, and any object that belongs in this set will be written inside. So what exactly are whole numbers? What are they consisting of? Whole numbers are just non-negative integers, right? So we start off with 0 because it's neither positive or negative. Then we have 1, 2, 3, so on all the way to the positive infinity. So whole numbers just consist of non-negative integers. Similarly, if we take a look at the set of natural numbers, natural numbers only consist of positive integers. So we no longer have 0 belonging to this set. We start off with 1, 2, 3, 4, and so on. We just have positive integers that belong in this set of natural numbers. And each of these objects in this set, they are known as elements of that set. So 1, 2, 3, 4, 5, 6, and so on. All of these are just elements of the set of natural numbers. And similarly, 0, 1, 2, 3, and so on. These are just the elements of whole numbers. So now if we take a look at a function, f of x is equal to 3x plus 2. We can imagine a function to be like a machine. So we have a machine here that takes some certain values of x, some inputs, to give out some corresponding outputs. So here we have x, which is just a dummy variable because we can easily replace x with some other symbol. So it's just a placeholder. We can easily write f of t, for example, which is equal to 3t plus 2, right? And both of these functions are completely identical and equivalent. So we can consider this variable to be our input and f of x will be our output. Now, according to the definition of a function, each input can only correspond to a single output, right? So if we have only one value of x, we can only get a corresponding single value of y. So say we have x is equal to 2, right? Then in this case, f of 2 is equal to 3 times 2 plus 2. All we're doing is just substituting this value of x into our function. So we have 6 plus 2, we get 8. So our output here is 8. So we only have a single output for a value of x. So if we have several outputs for a single value of our input, then that no longer satisfies the definition of a function. So for one input, there can only be a single output. Now, the domain of a function is just the set of all possible inputs. So basically, we have to find what are the possible values of x so that our function f of x is still defined. As in, for a certain value of x, we can still find a corresponding value or a corresponding output. So domain is just the set of all possible inputs, and similarly, the range is just the set of all possible outputs. right? So let's say we consider a function such as this. We have f of x is equal to 1 over x minus 2, right? So what happens if we have, let's say, some arbitrary number a and we divide it by 0? If we divide some arbitrary number by 0, then we get something that is undefined. Why is it undefined? It's because we cannot find any number that if we multiply it with 0, it will give us a. No number exists that if I multiply it with 0, it will give me back a. Because what do we know? We know that if we multiply any number with 0, let's say we multiply b with 0, then we will always get 0, right? So a divided by 0 cannot be equal to some defined value. It's going to be undefined, right? So because of this, since we have this expression where we have 1 divided by some term, we have to make sure that the denominator, it cannot be equal to 0. So we had x minus 2, right? That means x minus 2 cannot be equal to 0, because if it does, then this function is no longer defined. And f of x becomes undefined when x is equal to 2. That means that this is not a possible input that we can have. So we must exclude it from our domain, right? So x cannot be equal to 2. But if we take a look at this function, other than x is equal to 2, you can have any other value of x. Any other value of x is possible except for 2. So the domain for this function will be the set of all real numbers. So x, this symbol means belongs to, or is a member, or is an element of. So this just means belongs to the set of real numbers, with the exception that x cannot be equal to 2. Okay, so if you do not remember what a real number is, well, we can start by drawing a real number line. Let's say we have 0 in our origin, and on the right side we have 1, 2, 3, and in the negative direction we have minus 1, minus 2, minus 3, right? So any number that we can plot on this number line will be a real number. So we've previously discussed about the set of whole numbers as well as natural numbers. So you can see here we have integers that can be plotted on this number line. So we have 1, 2, 3, 4, 5, 6, and so on. That is the set of natural numbers. And for whole numbers, we have 0, 1, 2, 3, and so on. Similarly, we can also have rational numbers be plotted in our number line. So rational numbers are of this form p by q, where p and q are some constants given that q cannot be equal to 0. So for example, if I have 1 divided by 2, and this is a rational number, this is just equal to 0.5. But I can easily plot this on the real number line here. It will be around here, between 0 and 1. Similarly, if I can think of some irrational numbers such as pi or square root of 2, square root of 7, and so on, I can also plot these on the real number line, right? So the real number line consists of the set of rational numbers and irrational numbers. So we have irrational numbers as well as natural numbers, whole numbers, the set of integers. These are all real numbers. So x belongs to the set of all real numbers, with the exception that x cannot be equal to 2. So we can show it like this. We can have these curly brackets, and within these curly brackets we can place any number that cannot be part of our domain. Similarly, for f of x is equal to 1 over x minus 2, we can also see that if we were to find the range, our range can be any value except for 0, right? Because what do we have? We have 1 divided by some term, right? So 1 divided by any number cannot be equal to 0, right? There isn't a number that I can divide 1 with to give me 0. So f of x cannot be equal to 0. We can also show this more explicitly if we let y to be equal to f of x to be equal to 1 by x minus 2, right? And we can just solve this equation for x. So what we can do is we can multiply both sides with x minus 2. So we have y times x minus 2 equals to 1. And dividing both sides by y, we have x minus 2 is equal to 1 by y. Add 2 on both sides, so we have x is equal to 1 by y plus 2. And this is just 1 plus 2y over y, right? So we can see from this expression of x, this equation of x, that we have y in the denominator. That means that we cannot have y to be equal to 0 because then this will become undefined, right? So for our range, y or f of x belongs to the set of all real numbers except for 0, right? So this is our range. And so far, we have been dealing with functions that have only real numbers as inputs and real numbers as outputs. So for this topic, we will only deal with real numbers and as inputs and outputs. So real numbers as input and outputs, right? So this is only, we are only going to be looking at functions such as this, that only have real numbers as inputs as well as outputs. Okay, so all of the functions that we have looked at so far, they are also known as real valued functions. That means the functions only correspond to, well, they only have real numbers as outputs. Okay, so now I will explain something known as the interval notation. The interval notation is very important because we can easily express the domain and range in a more simple way. So let's consider some set x where x belongs to, where x is an element within the interval 5 and 2. So x is less than 5 but greater than 2. So all of the elements in this set are within this interval. So we have 3, 4, and that's it in terms of integers. So I can easily express this in interval notation as x belongs to the interval 2 and 5. So since 2 and 5 are not included in the interval, since we only have a less than sign, it's not less than or equal to. So since 2 and 5 are not included in the interval, then we use parentheses to denote this, right? If, however, we had x is less than or equal to 5, but greater than 2, then in that case, we can represent this as x belonging to the interval 2, comma, 5, but we represent this with a square bracket or a box bracket. So if 5 is included in the set, we use a square bracket, or if a number is included in the set, we use a square bracket. If it is not included, such as 2, then we use a parenthesis, right? So for the case of, well, if we're dealing with infinities, so let's say we have x is greater than or equal to 2. Let's say this is our domain, right? So that means what? Our possible values of x range from 2 all the way to positive infinity, right? So we can show this in interval notation as well. So we can say that x is an element of the interval from 2 to positive infinity. Once again, we are using square brackets here because 2 is included in the domain or in the interval, right? But when we're dealing with infinities, if we're dealing with positive infinity or negative infinity, since infinity is not something that is defined, we cannot include it in the set. So we have to use parentheses whenever we're dealing with infinities. So for the case of this positive infinity, we use a parenthesis. So if we go back to the equation we were looking at, we had f of x is equal to 1 over x minus 2. We saw that x cannot be equal to 2, right? So x belongs to the set of all real numbers where x cannot be equal to 2. So this was our domain. Another way of writing this in interval notation is we can say that x belongs to, so okay, a better way to explain this is, so for this domain, what are the possible values of x? X can exist in the interval from minus infinity up to 2, but 2 is not included, so I use this parenthesis. But x can also exist or can be part of this other interval that starts from 2 to positive infinity, right? So x can be a value in this interval as well as this interval, right? So we can show this easily with this symbol. So this symbol is the union. That means it's the union of these two intervals, meaning that x can belong to either this interval or both. So this is an entirely new set where x can belong in this interval or both. So we can also show the domain for this function using interval notation.